In one of the driest places on Earth, rocks move on their own. Death Valley, California, racetrack playa, a flat, dry lake bed stretches across the desert. And scattered across its surface are dozens of rocks, some weighing up to 700 pounds. Behind each rock is a trail, a long, winding track carved into the mud. The trails can stretch for hundreds of feet, proving the rocks have moved, but no one has ever seen them moving. For over a century, scientists proposed theories: powerful winds, magnetic fields, even aliens. Then, in 2014, researchers finally witnessed it. They captured the movement on camera. And the answer was more elegant than anyone imagined. This is the story of the sailing stones of Death Valley. Racetrack Playa sits in a remote corner of Death Valley National Park in California. It is 2.8 miles long and 1.3 miles wide. The surface is exceptionally flat. The northern end is only 1.5 inches higher than the southern end. The playa is a dry lake bed. Most of the year, it is bone dry, cracked mud, baking heat. Nothing grows here, nothing lives here. The rocks themselves come from the surrounding mountains. Dolomite and syenite eroded from the peaks. They tumble down due to erosion and come to rest on the playa surface. And then somehow, they move. The trails left behind are undeniable. Some tracks are straight, others curve and loop. A few rocks have left trails over 1,500 feet long. Rocks with rough bottoms leave straight tracks. Rocks with smooth bottoms wander. The phenomenon has been documented since 1948. Researchers have studied the tracks, measured them, photographed them. But until 2014, no one had ever seen the stones actually moving. It became one of geology's most enduring mysteries. Over the decades, scientists proposed multiple explanations. Theory 1: powerful winds. Death Valley is known for strong winds. Perhaps hurricane-force gusts simply pushed the rocks across the wet playa surface. But the math did not add up. Even the strongest winds could not move a 700-pound rock. And why would all the rocks move in different directions? Theory 2: dust devils. Small tornadoes form in the desert. Perhaps they picked up rocks and moved them. But dust devils are brief and localized. They could not explain the long, organized trails. Theory 3: magnetic fields. Some suggested the rocks contained iron and were pulled by magnetic forces in the earth. This was quickly disproven. The rocks are ordinary dolomite and syenite, no magnetic properties. Theory 4: algae or ice. Perhaps a slick layer of algae formed on the playa, making the surface frictionless. Or perhaps thick ice encased the rocks, allowing them to float and be pushed by wind. These theories were closer, but still not quite right. And then, of course, there were the less scientific explanations. Pranksters moving rocks at night, aliens, ghosts. The mystery persisted because no one could observe the phenomenon directly. The rocks only moved when no one was watching. In 2011, two cousins decided to solve the mystery once and for all. Richard Norris, a paleobiologist at Scripps Institution of Oceanography, and his cousin, James Norris, launched what they called the Slithering Stones Research Initiative. Their plan was ambitious. They would monitor the rocks continuously using technology that had not existed in earlier decades. They installed a high-resolution weather station near Racetrack Playa. The station could measure wind speed, temperature, and other conditions every second. Then they added 15 rocks of their own to the playa. Each rock was fitted with a GPS tracking unit. The GPS devices were placed in cavities drilled into the tops of the rocks along with battery packs. Finally, they set up time-lapse cameras to record the playa 24 hours a day. Then they waited. The researchers expected to wait years. The stones at Racetrack Playa are known to move only once every 2 or 3 years. Most tracks last for 3 or 4 years before erosion erases them. Ralph Lorenz, a planetary scientist working with the team, called it the most boring experiment ever. But in December 2013, something unexpected happened. Richard and James Norris arrived at Death Valley in early December 2013. What they found surprised them. The playa was covered with water. A shallow pond about 3 inches deep had formed after recent rains. This was unusual, but not unprecedented. Winter rains occasionally fill the playa, creating temporary lakes. Then overnight, the temperature dropped. The water froze. On December 4, 2013, the researchers were present when something remarkable happened. The ice covering the playa began to crack and shift, and the rocks started moving. On December 21st, Richard Norris heard popping and cracking sounds coming from all over the frozen pond surface. He turned to his cousin. "This is it," he said. The time-lapse cameras captured everything. The rocks were moving, slowly, almost imperceptibly, but they were moving. The GPS units recorded their paths. Some rocks traveled over 200 meters between December 2013 and January 2014. For the first time in history, scientists were watching the sailing stones in motion. The observations revealed exactly how the stones move. It requires a rare combination of conditions. First, the playa must flood. The water needs to be deep enough to freeze, but shallow enough to leave the rocks exposed. Second, temperatures must drop below freezing at night. This creates a thin sheet of ice across the pond. The ice is only 3 to 6 millimeters thick, about 1/4 of an inch, thin enough to be called window pane ice. Third, the ice must partially melt the next morning. As the sun warms the desert, the ice sheet begins to break apart into large floating panels. Some panels are tens of meters across. Fourth, light winds must blow across the playa. The winds do not need to be strong, just 3 to 5 meters per second, about 10 miles per hour. The wind pushes the floating ice panels, and the ice panels push the rocks. The stones move slowly, about 2 to 5 meters per minute, slow enough that you would not notice unless you were watching carefully. But over hours, the rocks travel significant distances. They leave trails in the soft mud beneath the ice and water. This process is called ice shove. It is common in polar regions where ice pushes against shorelines, but it had never been observed in a desert environment. The answer was elegant, simple, and entirely natural. The research team published their findings in August of 2014. The paper included GPS data, weather measurements, and time-lapse footage. For the first time, the sailing stones had been observed and documented in motion. The findings overturned previous theories. Hurricane-force winds were not needed. Thick ice was not required. The mechanism was far gentler than anyone expected. Light winds, thin ice, floating panels. That was all it took. The researchers noted that this combination of conditions is rare. The playa must flood, which happens infrequently in one of the driest places on Earth. Temperatures must be cold enough to freeze water, and conditions must be just right for the ice to break into large panels rather than melting entirely or staying solid. This explains why the stones move so rarely and why no one had witnessed it before. The mystery that had captivated scientists for over a century was solved. Today, visitors can still see the sailing stones at the playa. The location is remote. It requires a high-clearance 4-wheel drive vehicle to reach. The journey from the nearest facilities takes about 90 minutes each way on rough, unpaved roads. But for those who make the trip, the sight is extraordinary. Dozens of rocks scattered across the pale, dry surface, each with its own trail, some straight, some curved. Silent evidence of a phenomenon that happens only when conditions align perfectly. The National Park Service asks visitors not to disturb the rocks or walk on the trails. These features are fragile and rare. While the mystery has been solved, the sailing stones remain one of Death Valley's most remarkable natural wonders. A reminder that even in the age of technology, some phenomena still require patience and the right conditions to reveal their secrets. The sailing stones of Death Valley teach us something important about science. For over a century, people proposed elaborate theories: magnetic fields, aliens, supernatural forces. The answer was simpler: ice, wind, water, natural forces working in harmony. Sometimes the most mysterious phenomena have the most elegant explanations. We just need to be patient enough to observe them. The stones still move, rarely, quietly, when the conditions are just right. And now we know why. The sailing stones of Death Valley, a century-old mystery solved by patience, observation, and science. If you enjoyed this exploration of one of nature's most elegant phenomena, subscribe to Nocturne for more mysteries explained. Thanks for watching. Until next time, stay curious.